Hello there, I'm Mr. Math Guy, and today we're going to take a look at a 10-minute video on properties of logarithms. So there's three properties that we're going to take a look at in this section. The first one is called the product property. The product property says this: if you have a log of m times n in base b, that it could be rewritten as the log of m in base b plus the log of n in base b. And it's kind of similar to the exponential property, product property. If you have b to the m times b to the n, it was equal to the b to the m plus n power. So when you're multiplying with logarithms, you can separate it into two individual sums, all right? Log of m in base b plus the log of n in base b. So the second property we have is the quotient property. And it would say the log of m divided by n in base b is equal to the difference between the two logs, log of m in base b minus the log of n in base b. Kind of similar to the exponential property, where you have b to the m divided by b to the n is equal to the b to the m minus n. So when you're dividing with logarithms, you can separate it into a difference problem, to subtraction. The third property is called the power property. It says this, that the log of m to the nth power in base b is equal to n times the log of m in base b. So it's kind of like you move the exponent to the front and then multiply it by the log. With exponents, b to the m to the n power, you multiply b to the m times n power. So these are the three properties of logarithms that we're going to take a look at in this section. So if I'm working on expanding logarithms, and I have an example problem of log of AB, this would be in base 10 since there's no base written, then since it's the product property, this is the same thing as the log of A in base 10 plus the log of B in base 10. So when you multiply, you just simply separate it into two problems where you add them together to the sum of two. So if I have a problem like log of b to the fourth, again, this is in base 10 because there's no base written, then to expand this, this is the power one, where you say it's 4 log of b in base 10. So 4 log. So this exponent just simply moves to the front and you multiply. All right, let's take a look at another one. I have log of a over b. If you want to expand this, this is the quotient one. So it's just simply log of a in base 10 minus the log of b in base 10. This is the quotient property. What if we have the log of the square root of a? Well, first of all, what you need to think of is that this can be rewritten, because square roots are really just fractional exponents, as 1 over 2 power, right? Here's the 1, here's the index of 2, so it's a 1/2 power. Now this becomes just a power one, where you put the 1/2 in front times the log of a in base 10. Let's now work on taking an expression and combining it into a single logarithm. All right, so first thing we need to make sure is that the base number is the same in the logarithm. So they are, both bases are 3. Now, since this is being subtracted, this is your quotient property. This is the same thing as log in base 3, and in the quotient we divide 12 over 2. Now, you can do 12 over 2, so this is the same thing as log of 6 in base 3. 12 divided by 2 is 6. In this example problem, we have 4 times the log of 3 minus the log of 10. Again, there's no base written, so it assumes that it's in the base of 10. Both of them are in base of 10, so you can do this. So in this first one here, this first part is going to be a log. Since you have that 3 there, it's 3 to the 4th, right? And then we can just continue log of 9 in base 3. Now, since they're being divided, we could do this, or since they're being subtracted, they'd be divided. So it's 3 to the 4th, and 3 to the 4th is 81. So this is the same thing as 81 over 9. 81 over 9 is just 9. So it's log of 9 in base 10. In this next one, we have 3 different logarithms, and we're trying to combine them to a single logarithm. So first thing I want to take care of is I see this is going to be a power property. So this is going to be a log of 5 to the third power in base 4. All right, and you still got these other ones. Log of base 9, or 9 of base 4, and log of 3 in base 4. Now that we take care of the power one, now let's go ahead and let's just work left to right. So this part is going to be division, and then this part is going to be multiplication. So we will have the log, it's in base 4, and we have 9, but it's going to be 9 times this log of 3 in base 4, so that is 27 over 5 to the third. Well, 5 to the third is 125. 5 times 5 times 5. All right, so this one right here, we have log of 27 over 125 in base 4. This is combined to a single logarithm. In this next problem, we have 3 given approximations for log of 2 in base 10, log of 3 in base 10, log of 4 base 10. And we're asked to figure out what the log of 25 in base 10 is without the use of a calculator. With the calculator, we just punch it in, log of 25 equals, we got it. All right, but before calculators, they use tables, and so we're just trying to be able to figure this out without the use of a calculator. So what we would do is we'd say, well, we don't know log of 25, but we do know log 2, 3, 4. Isn't log of 25 the same thing as 5 squared? Yeah. 5 squared is 25, and we know the log of 5. So if we wanted to convert this, we could say, well, this is the same thing as 2 log of 5. Now, we know what log of 5 is. Log of 5 is approximately 0.6990. So it's twice of what 6.990 is, which is 1.3980. So instead of using a calculator, now we might have to use a calculator to do 2 times 0.6990, but we didn't have to have a calculator with logarithms on them. All right, we could just simplify with what we do know. Let's take a look at another one like this. So we have the log of 5 over 9. Well, we don't know what the log, we do know the log of 5. That's given to us. And this is going to be a quotient property. And this one would be same thing as 3 squared. Now we know 3. This would be log of 5 minus, use your power property, move the exponent to the front, log of 3. So log of 5 is 0.6990 from up top, minus 2 times the log of 3. Well, log of 3 is 0.4771. Now, using a calculator, 2 times 0.4771, and subtracting that from 0.6990, we get negative 0.2552. Now, here's where these properties really come in handy when you're trying to solve for logarithms. All right, so we got this part on the left. They're all base 5, so it's minus, so it's a quotient property. So combine these to a single logarithm would be x over 3 is equal to log of 8 in base 5. Now, since they're both log in base 5s, then it's kind of like these things just cancel out. And that means x over 3 is equal to 8. Now, figure out what x is. We multiply both sides by 3. And we get x is equal to 24. So if I'm trying to figure out what x is in this equation up here, right there, it is equal to 24 by using laws or properties of logarithms. And another example to solve for x, again, this would be the same thing as log of, in base 2, of x squared, the power property, and log in base 2 of 9. Now, again, since they're both log base 2, it's kind of like those two things just cancel. So you get x squared equals 9. Take the square root of both sides. X is equal to 3, and not negative 3 because you can't get negative 3 as an answer in logarithms. God bless.